Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Let's start with term 2 questions. Now, what is the frequency of a wave with period of 3 seconds? We know that frequency equal 1 over t period. Frequency equal 1 over 3. So frequency equal to 0.3. The unit is hertz. Hertz, which is equal to second power minus 1. Anyway, it's hertz. 1 over second. Yeah. Okay, let's go to the next question. What is the time period of wave of frequency 20 hertz? Also, period equal 1 over frequency. So, period equal 1 over 20. That means it's equal to 0.05 seconds. Okay. Next question. Now, identify the type of the wave. This is a longitudinal wave. As you know, we have transference wave and longitudinal wave. Since the vibrations are in the same direction of the wave, so it will be a longitudinal wave. So the answer is longitudinal wave. Now, if the wavelength of the waves, if the wave is 6 meters and the wave travels with a speed of 300 meters per second, find the frequency. We know that frequency equal velocity over wavelength. That means 300 over 6. So the answer is 50 hertz. Actually, basically, it's only substitution. If the frequency were doubled, what would the new wavelength be? So now the frequency is 100. So the wavelength will equal to 300 over 2 times 50, which is 100. So the answer is 3 meters. Next question, number 16. Read the question, please. The amplitude of the wave. The amplitude of the wave is 0.4 meter. How did we find that? Actually, since the distance between these 2 points is 0.8, the amplitude is half this distance, or half this, length. That means it's 0.4 meter. So we can say it's 0.8 over 2, just to make things clear. What is the wavelength of the wave? Now, from this point, like this, to this point, it's one wavelength. And this is a half wavelength. So this 4.5 is 1.5 wavelength. Because we have, let's give it a different color. This is one wave. And this is a half wave. So 1.5, the 4.5 meters is 1.5 meter, wavelength, sorry. So 4.5 divided by 1.5, that will give us the wavelength, one wavelength, which is 3 meter in this case. If the wave travels at speed of 60 meters per second, what is the frequency? Now we have the wavelength. We need to find the frequency. Frequency equal to the velocity of the wave over lambda, or the speed of the wave, sorry, over lambda. That means 60 over 3, which is 20 hertz. Again, hertz is 1 over second or second power minus 1. It's the same. Okay. Let's go to the next question. What is the amplitude of wave 1? What is the amplitude of wave 2? Actually, the amplitude of wave 1, this is the amplitude of wave 1, which is 10. And the amplitude of wave 2 is 5. So 10 centimeters. Yes, it's centimeters. And 5 centimeters. Always look at the axis. طيب, what is the period? So the period is the time needed to complete one complete wave. For wave 1, this is the first wave. So it's 0.4 seconds, right? For wave 2, it is the whole thing. So it is 0.8. So for first one, 0.4 seconds. For the second one, it's 0.8 seconds. What is the frequency of each one of them? Now, the frequency of the first period is, now the frequency is how many waves per second, right? So frequency equal 1 over period. Using this formula, we can find that the frequency for the first wave is 2.5 hertz. For the second one is 1.25 hertz. Right? That's it. Let's go to the next question. Question number 18. From the graph, what is the frequency of the wave? Again, here we need to find the period. This is the period, which is 4 seconds. So T equal 4 seconds. Frequency equal 1 over 4. That means 0.25 hertz. Okay. Now, let's go to the next topic or subtopic, 6.1. Which type of wave is a sound wave? We know that it's by definition, the sound wave is longitudinal wave. Now, in which of the below medium is the speed of sound greatest? Actually, it's in the solids. It goes like this. Solids have the highest speeds, then liquids, then gases. So that is the order. It depends on the density of the density of the material. So solids have usually are denser than liquids, which is denser than gases. Okay. Which of the following factors affect the speed at which sound travels? The density of the medium, yes, of course, we just said that. The temperature of the medium, of course, because it's also will also affect the speed of the sound. The elasticity of the medium, sure, also it will be one of the factors that affect the speed of the sound. So all of them will affect the speed of sound. Now, let's look at those. Okay. Which of the following affects the pitch of the and the loudness of the sound? هلا, we know that the pitch is like the difference between the, let's say, the boy's sound voice and the girl's voice. This difference is based on what? Based on the frequency. So the pitch related to the frequency. So it's not the amplitude, not the speed. It's one of those, C or B or C. The loudness of the sound depends on the amplitude. Higher amplitude means higher or louder sound. So it's B. The answer is B. Question number 23. Now please read the question. Okay, which of the following statements correctly describe the pitch of the and the loudness of the sound? Actually, we just talked about them. Which one has higher frequency? Actually, higher frequency means Q has higher frequency, so B has lower pitch. That's right. B have higher, no, that's not right. The third one, wave B is softer than wave Q. Yes, that is also right, clearly from the graph. And that's it for term 2. Thank you very much.